All right, let's look at section 9.3, problem 21. All right, this is an example where you have a non-separable equation, but use of change of variable, we can turn it into a separable equation. All right, so let's look at this one. All right, so original equation is y prime is equal to x plus y. We're going to use this substitution here. All right, so by taking a derivative of the substitution with respect to x, we can get du over dx is equal to, all right, derivative of x is just going to be 1, and then derivative of y is, you can write it as dy over dx, but I'm gonna use y prime so that I can match this with this guy right here. All right, so when you have that, then we can just start rewriting the original differential equation. All right, so we have, maybe I'm gonna solve this for y prime, so by subtracting 1. So you have a du over dx minus 1 is equal to y prime. All right, and also by the substitution, we know that the right hand side of the original differential equation is going to be simply u. All right, so the equation becomes this. So y prime is du over dx minus 1. All right, so this is y prime is equal to, right hand side is going to be u. All right, then we can just add 1 to both sides. Du over dx is equal to simply u plus 1. All right, so this is a separable equation. So we're going to divide through by u plus 1. All right, so divide through by quantity u plus 1. You will get 1 over u plus 1 du over dx is equal to 1, right? Then we can take the integral of both sides with respect to x. Integrate with respect to x. All right, then we can cancel dx here and dx there. So antiderivative of 1 over u plus 1 is natural log of absolute value of u plus 1. Then antiderivative of 1 with respect to x is going to be just x, right? And then plus some constant. I'm going to call it the C1 because I might have to use C for something else. All right, then we can raise e to both sides. So you get e to the natural log of absolute value of u plus 1 is equal to e to the x plus c1. This is going to be e to the x times e to the c1. Right? You can see that when you compose inverse functions together, they basically cancel out each other. So you get this. Right? Absolute value of u plus 1 is equal to, all right, I'm going to write the e to the c1 first, times e to the x. All right, so if you take away the absolute value sign, you're going to get this. All right, so u plus 1 is equal to, I guess we have to look at the plus or minus option. So e to the c1, e to the x. All right, but since plus or minus e to the c1 is just a number, so I'm going to just use c for this guy. Then this is going to be c times e to the x. All right, so if you're looking for u, then we can simply subtract 1. So we have a u is equal to c times e to the x minus 1. All right, but remember the substitution, right? U is x plus y, so we have, so from here, we have x plus y, which is the same thing as u, is equal to c times e to the x minus 1. All right, but remember that the y is the solution we're looking for. We can just subtract the x, so that we have y is equal to c times e to the x. I'll probably put the minus x right here and a minus 1. All right, so this is the solution of the original differential equation. All right, so as you can see that we can turn non-separable equation into a separable equation using this change of variable. And solve for u, then once you have a solution for u, then we can just rewrite it back to the expression for y. All right, that's how you solve this problem. All right, that's it. I hope that this was clear.